With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. A sonic source of frequency N0 is equals to 272 Hz is moving along horizontal circle of radius 3 meter with a speed of 10 meter per second. The stationary receiver lies in the plane at a distance of 5 meter from the center of the circle. The sound is in air, like sound speed is in air is this 330 meter per second. Then you have to check out of ABCD which option is the correct one. So if I talk about, if you see here, the first option is about the minimum frequency, and in second option the maximum frequency comes, right? So basically the observer is moving on the circle, right? So if the observer is moving on the circle, we know that the Doppler's effect, if the observer move toward the source, we write like if you see, I will write the apparent frequency is equals to the velocity of the observer by velocity of the sound original frequency. So if we talk about the observer velocity, when it will be directed toward the source, it will be plus sign. When it will be directed away from the source, it will be minus sign. But here if you see, there will be a component, right? There will be a component, since we know that like if the observer and the source are, like if you see, this is the source and this is the observer, and observer is having a velocity perpendicular to the line joining the source and the observer, the frequency will not change, because the frequency only depends on the component of the observer velocity along the line joining O and S. So I will write component along the line joining OS is considered. O is observer is considered. Now if you see here, the line joining, if I talk about, so it is moving on a circle. So it will be maximum and maximum when it will be along the line joining ONS like this. Like if it will be here, and the line joining the receiver and the observer and the velocity are parallel. And like this, when it is directed toward, it will be maximum, and when it will be directed away, it will be minimum. And this angle is 2 theta, right? So if I calculate the minimum frequency, we can just put the value here. So as we have already seen, the apparent frequency is V minus V0. So here if you see, all the component is directed along the line joining observer and the source. So I will write it as V minus V0 by V into F. So this will be the minimum frequency, right? So if you see here, the original frequency, it is 272, and this is 10, and the sound velocity is 330. So I will write 330 minus 10 by 330 into 272. Original frequency is 272. So basically you will write 332 by 330, that is this, into 272, right? So if you write down, if you solve this, 272 into this will get cancelled out, and I will write 272 into 32, it is in division 33. So it will be Now if you see the options here, 264. So yes, this option is the correct one. We already got this. It is nearly equals to 264. And this will be the minimum frequency, because here it is directed directly away from the source, right? So this will be the minimum frequency. Now, so A option is the correct one, 264. And at t goes to 0, the receiver receives minimum frequency. So it means that at t goes to 0, the observer is at here, like source is at here. So now we have to find out the value of time when it receives the maximum frequency. Then you can see it will receive the maximum frequency here. So you have to rotate this much angle, right? And you can calculate this theta. If you see this distance is given, it is 5 meter and this is 3 meter, right? So if you see, this is 5 meter and this is 3 meter. So this angle will be 53 degree and this angle will also be 53 degrees. So how much angle it have to rotate, right? So 180 minus 53 minus 53. So it will be 74 degree. So 2 plus 180. So it will be 254 degree. Okay. This much angle the sound producer should have to rotate, right? And how much time it will take to rotate this much? If you see, the velocity is already given. Velocity of this sound source is this, right? And it have to rotate 254 degree, right? So now we can calculate the time to rotate. So if I calculate the omega will be simply V by R. V is 10, R is 3. If you see the R here, R is 3. So I will write 10 by 3. Angle should be rotated, it is 254, but it is in degree. So you can convert it into radian by multiplying it with this, right? So time interval will be the angle rotated by the omega is 10 by 3. Right? So what we wrote here, this is theta by omega. Now you can solve it, right? Now you can solve it. So it will be, if you see, 254 into 3, it will be, so I will write it is 127 by, if you see, we are cancelling it with 6 and this will be 300. And this will be the time interval. So now you can see here the time interval will be this. Now the sound wave pulse emitted by the source at A and C will be as with the actual frequency. So as I already told you in the starting, that the component only along the line joining ONS is considered. So when it will be at A and C, it will be perpendicular to the line joining. So what will happen when it is perpendicular to the line joining? It won't change. So it will be same as that of the actual frequency. So yes, so A, C, D are the correct option. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.